Okay. Hello once more. Let's make our next lecture, our next recording. Today, we should move to the main laws of electrical engineering. It's three laws that calls Ohm law and Kirchhoff law for current and Kirchhoff law for voltage. Before it, we will discuss a couple things about simplification of mathematical model of electrical circle and make quick revision what was the previous time. The previous time, the main idea, we discussed that we are building some mathematical model of processes of generation, transportation and consuming of electricity, such mathematical model based on the main physical processes. And for one hand, we are trying to make it as much simple as we could to make our calculation more quick, also computer calculation. And on the other hand, this model should be detailed to take in account the main things, the main processes that we have, and to that we could obtain the main numbers in accurate way, that our numbers that we found will be correct. For this purpose, we start from more simple model that we called okay, we called I don't see this main topic, but I will tell it in words. We called it linear electric circle. We mean that all our elements was linear, that is constant. Also direct current, the case of constant value of current and voltages, and with such called state process without any disturbances, without any switching on, switching off, connections, disconnections, just our system work in the general way, and with parameters that concentrated in material point without any dimensions. That we are starting to build the mathematical model of general electrical object or electrical system. It could be just lots of different objects starting from some device and moving from some electrical network with lots of elements inside. But it is linear, working on direct current. Both of these parameters are constants. Also without any dimensions. I will point it like this. And working in state mode, that is mean that topology of our systems stays the same. In working in state mode. As four general main points in our mathematical model. Then we are starting to build it. We divide on all main things on consumers and generators, operating with basic physical properties as voltage, current, and resistivity, which connects voltage and current and describe the property of parts of system, wires, equipment, and so on. And after we divide all our elements on generator and consumers, we describe two types of generators. And as we were speaking, that voltage and current and resistivity connected in one equation, the Ohm law. And two variants of sources, voltage source and current source. And we could, in such mathematical model with such four main assumptions, build some view of electrical circle. It is called a circular model or just electrical circle. And the main topological elements of this circle is node, branch, and loop. And starting from this model, we could make some calculations, try to find some operational modes of this system. Also, we were talking about two opposite situations without any load, without any consumption, as short circle and open circle, because any other consumption will be just between these two limit points. And we finished on the formulation on the main laws. For now, just let show them as formula. Then we'll speak about some simplification of electrical circle. And then we'll move more detail about laws and equations, how they could be made, starting from these formulas. Then, quite useful that all mathematics that we will build during this semester just ground on three main laws, as Ohm law, which connects current, voltage, and resistivity of passive object that includes only resistor, or it could be also branch with active and passive elements, also with source inside it. It's just the same formula transformed dependently how many elements or what type of elements do we have. We could write this formula, this Ohm law, for a couple of resistors. We could write it for resistor and source, just add source with appropriate sign depending on the direction. It's not so important because all this transformation is just one general formula. In most general case, we could write the Ohm law like this. All sources that we have inside branch, all resistors that we have inside branch, and the voltage which applied on this branch. In such way, we could describe the current which flow inside this branch. Only one main restriction, that it shouldn't be any additional connections. It shouldn't be any connections with other branch to divide current. That is why current should stay the same, only one value. It is the most general form for this current. Then other two laws that grounds on the conservation law, they are called Kirchhoff laws for current and for voltage. For current, it describes the total current in some points, that total current that inflow in some node or couple of objects equals total current that outflow this node or some part of system. It is just conservation of charge, that total charge inflow should equal total charge outflow, and the total charge and or total current, which is charge per time, should stayed the same. Inflow equals outflow. The same for voltage. The second Kirchhoff law or voltage Kirchhoff law tells us about voltage. In general form, it is written like this. For current in general form, here it is. For total current with direction, some will be positive, some will be negative. Total current, depending on the sign, equals 0. And the same for voltage. For any closed path that we called mesh, for any closed loop or mesh, total voltage should equal 0. The total voltage of generators, which gives electricity, should equal total voltage of consumer, which consumes electricity. Total voltage of generators, 1, 2, 3, equals total voltage of resistors, also 1, 2, 3. It is just 3 main laws about electrical engineering, and then we will add some mathematics depending on complexity of model, depending on complexity of elements. But first of all, that you should learn the formulation of these 3 laws. Then, how we could simplify our model except of mathematics and except of assumption. We simplify it by consumers, looking how many resistors do we have, and could we make the number of resistors smaller. That is called combinations in electrical circles, and I propose to speak firstly about combinations, and after it return more detail to the laws and speak about laws. Because if I'm not mistaken, I think with teacher Ludmila, you should yesterday speak about combinations and see a couple of tasks on practice. Yes? Was it? Did you connect with teacher Ludmila yesterday?
No.
No. Okay.
I joined the class, but just me. So teachers start the review our class next week.
Okay, understand. Then next week you will start from this situation. You moved the class to the next week because only you were joined, yes? Because other students was absent.
Yeah.
Okay. Then because we speak with teacher Ludmila before the class, and we deal that we should start from the combinations and then moving for more complex mathematical calculations. Okay, you will do it next week, and now it is better to look through it firstly on lecture. That even better than I think. Okay, first of all, our main goal to decrease the number of elements to make our model more simple. Because general, we could see lots of elements. The circle could be much more complex with 10, 20, 30, or 100 elements. And if we could decrease the number of them, it will be much better for us for our calculation. How we could decrease it? Starting from basic physical transformation, I think from the course of general physics or course of electricity and magnetics, it could be discussed that all elements that connected with the same current is called series connection if current stayed the same, or elements which connected with the same voltage, the voltage is the same, is called parallel. And it is the first way to decrease the number of elements. First of all, if elements connected one by one, the starting point from the next connected to the ending point of the previous. They are just one by one, and the important point that no additional connection, no additional branches between them, because if this branch will be present, the current will divide, and it will not be serial connection in such situation. Only without any additional connection, the current should stay the same. Where it is, here it is. The current I should stay the same for each element. In such way, we know that total voltage of all elements should equal adding of voltages of each element separately. Then if we will add all voltages, we will obtain the total voltage on the beginning. And if we will transform voltage using the Ohm law into the current and resistivity for each of element in initial circle, we will get the formula for total current and total resistivity of the whole circle, starting from the whole voltage. And because the current is the same, why is the same? Because we don't have any additional connection. The current hasn't any other path for flow, only one path for flow. That is why it is the same number in each formula. Then the total resistivity will be sum of all resistivities in the circle. And we could replace 4 elements as one total element. For example, if we will take resistivities 10 ohm, 20 ohm, 5 ohm, and for example, also 10 ohm for resistors, we could just add them 30, 35, 45. And total resistivity will be 45. And we could replace, instead of this circle, one element with 45 ohms. It is quite comfortable for further calculation. Also, we could do the same with active branch. If we have additional sources of voltage inside this branch, we could add separately resistances in total resistor, and we could add separately sources into a total source, only depending on the direction, because for resistors, they always add with plus, but for sources, how we add them depends on the direction of source. For example, if we have 10, 20, and 5 ohms, and for example, 20 volts, 40 volts, and 30 volts, then we are looking on the direction of the arrow. For resistors, it will be 35. For sources, it will be the same direction that we want to obtain, 20, minus 40, because of the opposite direction, plus 30. And it will be 60 minus 40, 50 minus 40, it will be 10 volts. Instead of this big circle, we could replace this one. All of this is called series connection. Then the opposite type of simplification is parallel connection. We looking on the voltage. If the voltage, it is the main condition. If the voltage stays the same on the element, we just looking on potential. We have potential as an energetic characteristic of the point, for example, phi A, and potential on the opposite point, phi B. This potential is moving through all wires, through all metal connection, and on each of starting point of element will be the same potential. Because metal object is the equipotential surface, then it means that all points of metal will be the same value of potential. And for opposite part, the same idea with potential B. Potential moves through the metal wire. And we obtain that for each element, we have the same voltage. Voltage AB for total circle, voltage AB for first element, AB for second element, AB for the last element. All elements with AB. It is called parallel constant voltage. And we could replace resistivities as the total one. How we could do it? We could write the formula about current Kirchhoff law, that total current that inflow will equal total currents that outflow. It will divide on 4 currents, as you see. And initial current will equal the sum of all other currents. And each of current we could replace using the Ohm law, that total current as voltage divide on total resistivity, first current as the same voltage divide on the first resistivity, and for each of current we are writing the same voltage over resistivity. And we could divide on the same voltage in each part of formula and obtain total resistivity. It is written as opposite formula as 1 over resistivity, as conductivity. 1 over ohm, it is conductivity in Siemens. And it's called then for parallel circle. Total conductivity equals sum of all conductivities, or 1 over total resistivity equals 1 over all resistivities adding each other. The formula like this. We could say that for serial connection, Here it is. For serial connection, we are adding resistivities. For parallel connection, we are adding conductivities. And we approve it from the general formula, from the general laws of Kirchhoff and Ohm law. And using this, we could, we could find the total resistivity for any circle, simplify lots of elements as just one. Only difference about which point we should measure the total voltage. For example, we are taking measurement device as we called ohm meter. It gives us value of resistivity, and we could connect it to any part of the circle to measure the value of resistivity between points. For example, we want to measure resistivity between points 1 and 1, like I connect here. How it will be? How we could measure it? We are looking which type of connection do we have. First of all, from the point 1, if we are making some current, the current will divide on two paths. Because here we have a nodal point, or let it show. For example, and as green one, nodal point. Then this current will flow, and the point number 2 is disconnected. It isn't connected on any other point. That is why current without any deviation, without any dividing, will flow just to another point, because this point number 2 is disconnected. We don't see anything near it. Then we have situation of two serial resistances, R2, let it be written here, R2 plus R3. It is 160 ohms, and it is parallel to 160. Let it be called R23, the total resistivity. And this R23 is parallel to R1. We should use formula that 1 over 123, the total resistivity, equals 1 over R1 plus 1 over R23. And it will be 1 over 160 plus 1 over 160. It will be 2 over 160 or 1 over 80. And because it is opposite for resistivity as conductivity, we could write then the answer resistivity of all these three elements will be 80 ohms. 80 ohms. And then instead of these three elements, we could replace the circle as 80 plus the 40 that left, plus 40. And that's all. It will be 120, and our measurement device will show us 120 ohms of resistivity. It will be the answer in this case. Also, please pay attention that if you have two the same resistivities in parallel, you always could divide them on 2 and obtain the answer just without any additional calculation. For example, if you have 200 in parallel to 200, the answer will be 100. If you, for example, take in 50 in parallel with 50, the answer will be 100. 25, sorry, 25 in parallel. If you are taking in serial 200 and 200, the answer will be 400. And 50 and 50 serial, the answer will be 100. In parallel, the same resistivity you are dividing per 2. In serial, the same resistivity you are multiplying per 2. Here is the answer. Do you have any questions? How we found the resistivity of the circle?
No.
Is everything clear? Yeah?
Yeah, clear. Thanks.
Okay. Okay, perfect. How about you, Jamil? Is everything clear? Is everything fine? Okay, I think if the silence, then or clear or not exactly present. Okay, let's move forward. How this situation could be transformed? For example, if we are looking on points 2 and 2, here is open circle because infinity high resistance. If we are connecting them and obtain short circle and making the same, we are taking ohmmeter as measurement device and want to replace this circle as one resistor, as one total resistor using the measurements of ohmmeter. What we should to do? We should find how these elements are connected and how they could be replaced. It could be made using the potentials. We have potential number 1 here. Then we have potential, for example, number 2 here and here, moving on the single wire. Then we have potential number 3 on the central point. And the last one here also be potential number 2 because of connecting wire. What does it mean? If we look on the resistors 2 and 4, they have the same voltage because voltage 3,2 and 3,2 on both of them, then it means then they are in parallel. In this situation, first of all, we could replace resistivities in parallel, 40 and 40, and obtain 20 ohms. You may ask how we should know from what resistors we should start, and if we want to start from the first one or from the third one, what should we do? not every resistors could be replaced in the order than you want. Sometime you should find the appropriate order and start not from any resistor, but from the concrete one. You are looking on the first. It has different voltage from all other, because on the first you have voltage 1, 3, on the third you have voltage 1, 2, on the second 3, 2, and on the number 4 also 3, 2. The resistor 1 has different voltage from all other. And also you see that here is point and current will divide, and this resistor also has different current. Then it's mean that this resistor isn't serial and also isn't parallel for all other. Then it's mean that you cannot start from this resistor. Also, you are looking on resistor number 3. It has different voltage from all others and different currents, because current through the third resistor, it also will divide in this point and will flow in different direction. That is mean that also you cannot start from the resistor number 3, voltage differs from other, and current also differs from other. For example, if near resistor 3 would be some resistor 5, you can start from it and add them in serial connection. Just add them. But in this situation, you are moving forward and you look that second and fourth resistor have the same voltage, and you could start from them, obtaining 20. Then you will have circle like this. You will have circle that $120, $160, and instead of these two, you are adding 20. On what point you should add it? Between 3 and 2. Between point 3 and point number 2. The first wire for measurement will be point number 1, and second wire for measurement will be point number 2. You are just adding them as one single element. And what do you obtain? You obtain serial connection 160 plus 20. It will be 180 total resistivity instead of these two, and 180 in parallel to 120. You could transform formula in more simple way, in more comfortable way. The total resistivity for two parallel elements you could transform this formula to move it for the same bottom part, multiply upper and bottom part on R2 in the first part of formula, and multiply on R1 in the second part. Then it will be 1 over R total equals R1 plus R2 over R1 plus R2, and you could reverse it into the way that total resistivity of two parallel elements will equal R1, R2 over R1 plus R2. Generally, if you have only two elements, all engineers use this formula because it is quite quicker for calculation than using conductivities. Multiplication divide on the adding. And if you have 120 and 180, you should take multiplication of them and divide on the adding on 300. Multiplication over adding s equals 300, it will be 72. Then the total answer of this whole circle, it will be 72. And you could replace the whole circle as a single resistor, 72. That is the second task. Okay, I will not ask every time, is everything okay? Is everything clear? If you will have any questions about some steps, please, you could ask anytime without waiting that I finish. Just in any time for some step, you could ask, please, could you repeat something? If you are keeping silence, then I think that everything is okay and we could move forward.
Yeah, it's okay. I already took this subject kind of.
Okay. Sorry. Yes, yes.
I said for me, it's all okay. I already took this subject before, kind of physics to resistance and what's it called, and R, and then conductors we will add, and then we will add other things to calculate all of this.
Okay, okay, perfect, Jamil. Then let's moving forward. We are starting from the simplest case, and then we will make our calculation more complex. Then just let's see how it will be on the next classes later on the semester. Okay, then, for example, let's try do the same for other formula, like here. If we want to measure the resistivity of the circle in open mode, how do you think which step it will take and which answer we will obtain here? How do you think which steps should we take? Who know any of you?
What's it called? Let me read the question again because I am in a car. Determine the if points 2 and 2 from open circuits and points 2 and 2 are short circuits. Okay.
I mean, you are looking on this circle and try to calculate total resistivities, how it is pointed here. It's because we have only here.
We want from 1 to 2, yes, not from 1 comma to 2 comma, yes.
From 1 to
One?
1 with dot. Yes, from 1 to 1 with dot. The
Okay.
total resistivity between these 2 points.
So total resistivity between these 2 points will be going direct through R1 and R4. If that's
And what
and
about these two?
to this,
R3 and R2.
there's another calculation for R3 and R2. It will go through R3 and R2 but I don't remember the calculation for R3 because it's another calculation for R3 and R2, not like R1 and R4. R1 and R4 we شو اسمه we add them together because they're straight line, they're not parallel.
Did you speak about R1 and R4 or R3 and R2 when you saying about adding them? Just straight.
Wait, no, yes, R3 and R2 are adding them together.
Okay, yeah, you're adding them.
Okay, and R1 and R2 because they're parallel, and R1 and R4 I don't remember.
Okay, yeah, you're adding them in serial, R3 and R2 because they are in serial. Then you could add with R1 in parallel because you have 2 points with the same voltages, here and here, and you could take in parallel 300 and 700. It will be like this. It will be according to formula that I wrote, multiplication and divide on their adding. 300 on 700 over 1000, it will be 210. Then instead of all them,
210 will add to 600.
Yes.
Yeah,
Okay, and the total answer will be 810 here. Okay, for now, let's have a small break, about 5 minutes, just to refresh our thoughts, just to make a couple of steps on our legs. And I will not stop this conference and video, just small break and then continue. You may stay here and I also will be here. Okay?
Just pause recording. Okay.
Yeah, just without stopping recording, just small break, 5 minutes. You may think about the last question, while we are resting. What will be the answer? The same situation with measurements. If we are connecting these 2 points, 2 and 2 with dot, if here will be electrical connection. But for now, let's have a small break, 5 minutes, and then we'll continue. Okay. Okay, let's continue. Then,
I thought about it. It's very easy. Basically, we will add 300 and 300. It will become 600. And then that's 600. We will multiply 600 by 400 and divide them by 1000. I don't know how much it will become exactly because I didn't use the calculator. And then that answer will add to 600.
not exactly. Some thoughts correct, some thoughts not exactly. Maybe what do you think about it?
I think R2 multiply R4 then over R2 plus R4
or multiply or plus. Which of these both answers?
Sorry. I think okay,
adding.
you see.
No, because if I'm not mistaken, first you told multiply and then told add. That I'm asking what of the
because I think it's parallel circuits. You know, you said before.
Yeah. I agree because here is metal wire. All these points will be with the same potential. For example, if here some point number 3, the voltage will be equal. The voltage on second and 4 will be the same. And yeah, you are right. We are using those formula, then they should be multiplied and then divide on the adding. It will be 600 on. Yep. Yeah, it will be 240 as the answer on these two.
And then n plus R1.
Yes. Yes. And
and the R1 and the R24 is in the same current.
You're adding them, and the first step of transformation will be like this. The points, you are adding them, obtaining 540. And the last step?
And 540 multiply 300 or 540 plus 300. Yeah. This is
they will be in parallel or in serial. How we should do it with these two?
Parallel
yes.
current.
Yeah, perfect. You are right. We are doing exactly the same that we did here. They also in parallel. Then we should take this 540, multiply on 300, divide on 840 and obtain 193 ohms. Then the answer here for this task will be 193 ohms. Yeah, okay, perfect. I think the general idea is clear. Both of you generally understand how the things will go, and you will train with teacher Ludmila this part of material, this equivalent transformation on practice. Also, I recommend you, I will send some practical tasks just for make this material more clear, more understandable. You could look through a couple of starting tasks inside this file, for example, here, just trying to add the resistivities as it is told in the initial data. And if everything will be fine, if you are doing it quite easily and everything and understand, that is perfect. Then it means that this part of material you deal with. You could try do a couple of these tasks, and if everything okay, just we could move forward. For now, let's return to the main laws, because this equivalent transformation we will need further for simplification. And for now, let's return to the main laws, to their basic three equations. First of all, if we have only resistor, we told that is voltage over resistivity equal current. If we have couple of resistors, then in bottom side will be adding of this serial connection. We are simplifying them as serial connection, just adding. If we have active source, if source has the same direction as current, you should add it when finding current, because this source intensify the current and made it stronger. If the source in opposite way, you are taking difference voltage minus electromotive force, because this current will make source will make the current weaker. That is why in first case you are taking plus, in second case you are taking minus. And that is why the general form, it is here. For any case of branch, you could use the general formula from the Ohm law. You could write it on some paper just to see it every time near the eyes. It is the first main thing that you will need every time. Then, as we speak about current, the total current in point equals 0. For example, here you should add I1 plus I3 plus I4 and equal I2. What does it mean? It means if you have current, for example, 5 amperes, 10 amperes, and 20 amperes, then the total current, you are adding all the inflow currents, then the total outflow current will be 35 amperes. You could find it easily. For example, other task, if you have total current 50 amperes and some current, for example, 10 and 20, and you don't know current number 3, you also could easily find it. 50 minus 20 minus 10, then this current also should be 20 amperes. That to make this formula be true. It is Also quite useful thing for current searching. The same for voltage. The total voltage of resistors will be the total voltage of sources. For example, if you have some task, then you have 30 volt source number 4, for example, 20 volts source number 5, and 10 volts source number 6. Also, you have some consumers, for example, 10 volts on the resistor. I mean, not resistivity of resistor, but already voltage that drop on this resistor. As resistivity multiply on current. This voltage, we could find that the current multiply on the resistivity, number 2. And this voltage equal 10 volts. Also, for example, let it be 20 volts, and let's find the voltage on the resistor number 1. What voltage do we have here? How it could be found? We are moving through the circle and adding all voltages depending on the direction. First voltage, the same direction as green arrow. We are taking it with plus in the sources. Then the second voltage is opposite directed. As you see, the arrow is opposite. You are taking it with minus. And the last one, the same directed as green arrow. You are taking it with plus. And as you see, the total voltage, 30 minus 20 will be 10, plus 10 will be 20. The total voltage will be 20 volts. It should be equal consumers, 3 resistors. What do you have inside resistors? You see that current moving the same way, current through the resistor, moving the same way as green arrow, it will be 10 volts with plus. And also current number 3 in the opposite direction, as you see the arrow here, it is opposite directed. Then it should be with minus 20. And unknown variable. This unknown variable of voltage, let it be x. Then here you obtain minus 10. And you have equation that minus 10 volt plus x equals 20 volts. Then it means that your x should be 30. Then it means that the voltage on the last resistor should be plus 30 volts. It is your answer. That is how it works. You could find some unknown variable from voltage equation, and in previous case, some unknown variable in current equation from the Kirchhoff law. Is this okay? Is everything clear about it?
Yes, clear.
Okay, perfect. How about you, Jamil? Is everything clear?
Yeah.
Okay, perfect. Then how we use it mathematically in more complex mathematical model. For example, we take some circle. It could be, for example, some house with couple of rooms and equipment inside these rooms, some sources of energy, and some consumers. We want to calculate the process inside this house, what current will flow inside the wires. What initial data generally we know? Generally, we know sources, the value of voltages, or let me do it in this way. One moment. To see the picture during all calculations. Just one moment. Yeah, here it is. What generally do we have? We have the value of voltage sources, the value of current source in amperes, and the value of resistances in ohms inside our circle. And we are asked what currents do we have inside it. What currents do we have in each wire? First of all, this current will equal source because it is a current source. It will be defined variable, but all other we have to find. We have unknown 5 currents. 5 currents, 5 variables that we have to find. If we have 5 variables, then we have to write some 5 equations for solve this system. It is defined mathematically. And we are writing equations according to laws that we have. We could write, for example, Ohm law for each of current. It tells us about potential difference, divide on resistivity, and taking in account source if this source present near the resistor. It could be written in this way, 5 equations. But the main problem is that we don't know the potentials. The potentials also is unknown variables. That is why before we don't know voltages, we cannot use the Ohm law because we cannot get answer. Then we could use Kirchhoff's law. We could write the current law and write some laws about voltages, how it should looks like. It should be like here. For example, for any circle, for any mesh, we could write the Kirchhoff law. Only one exception, if we have current source, we don't write the Kirchhoff law inside the circle, but I will speak about it the next time, not to mix lots of information. Just for now, our main goal, our main purpose, to write in some way 5 equations, to find 5 unknown variables, to see how we could use this information for more complex calculation that we see. Let's write, for example, Kirchhoff law about voltages in this circle. How it will be? It will be sources, E4, equal consumers. Consumers, two resistors. I2 on R2 currents plus I5 on R5. It will be equation number 1. The second equation will be in upper mesh. We have two sources. One, the same directed as arrow. The second one is opposite directed, comparing with this orange arrow. It will be taken with minus. And the resistances. First current, the same directed. We are taking it with plus. Then current number 3, opposite directed, and current number 2 is opposite directed to this arrow. That is why in both cases we are taking them with minus. Also, we could write laws according to the first Kirchhoff law, according to the current in each point. We could write in point number 1 that inflow current I4 equal current I2 plus I1. Here it is. Then current, for example, in second point, that current number I2 inflow equals current number 3 plus current number 5. And the last one, in point number 3, inflow current 1 plus inflow current J6, which we know equals I and plus current number 3, also inflow, equals 0. It means that at least one of these current will be with negative sign. But mathematically, everything is correct. And we have 1, 2, 3, 4, 5 equations. What data do we have? We have sources. We have this information, and we have resistances. Resistances. Also, we know these values, and we have the value of current source. 5 equations with 5 unknown variables. Here it is. Mathematically, this system is quite easily could be solved using, for example, matrix form or any program for solution. We could find all these 5 currents for this system. That is how it's works. For today, we will not go very deeply for this information, how to build this equation, how to solve these systems, what different will be in different circles. For today, it's just the idea to see how Kirchhoff's law could be written and how they could form the closed mathematical system for obtain solution. Because on practice, that is how it's done. To obtain necessary number of equations and solve them mathematically. For example, in matrix form. Just one of example how this Kirchhoff's laws could be implemented. For the main idea, maybe any questions or suggestions, please welcome. Okay. Then let's return to our material. We almost finished. Then I proposed you please look through this material, what is written here in lecture number 2 about basic laws, and in lecture number 3 about equivalent transformation. It is what the main ideas, what we speak to. One last additional point is about power, because you can control not only voltage and current, but you could control power conservation law. The total energy that sources gave you equals total energies that consumers takes from the circle. Energy is integral of power per time, and in direct current, power is constant. That is why energy equals power just simply divide per time. That is why if energy stays the same, then power also should stay the same. Power of source equal power of consumer. Power of consumer could be found as joule heating, as for example, square of current multiply on resistivity for the resistor. And power of sources could be found as multiplication of voltage and current for sources. Here it is, the general idea. Voltage source, electromotive multiply on current, current source, voltage multiply on current of this source, and power of loads of resistors, joule heating. Altogether, this equation should stay the same, just as energy conservation law. I think we will discuss it more deeply next time and take a couple of practical examples also next time. For today, just general ideas about serial and parallel connection, about Ohm law and current and voltage Kirchhoff law, and general idea about power balance. It is called power balance. For today, I think that's all. I think that's enough about new material.
Okay, thanks.
Welcome. Was glad to hear you. Then wish you a nice day. Good luck and see you next week.
Then see you next week.
Thank you. Goodbye. Also, goodbye, Jamil.